Hello everyone, I'm Oliver. Have been working for MapLibre, and today this talk is about text rendering with MapLibre. So it will have first a part where I tell you a little bit about the MapLibre organization, and then later I talk about text rendering. First to start with, thank you for having us here. There's 3 people from MapLibre who came, so it's cool that you invited us, and it's nice that you organized all of this. And before we start, about myself, I have been working as coordinator for MapLibre for the last 2 years. Now I want to transition to something new, which I hope will be more like contracting, consulting, freelance work in the sort of maps and location space. Yeah. Connect with me on LinkedIn, then we can stay in touch. You find my name and stuff there. Yes, so the MapLibre organization. MapLibre organization has 2 projects. One of them is MapLibre Native. That's a base map rendering engine for iOS and Android mainly. And the other is MapLibre JS, which is for web browsers, right? Map rendering web browsers. These are forks from Mapbox libraries. The fork happened when Mapbox changed their license in December 2020. So we inherited the code from Mapbox and continued to maintain it as free and open source project. Today here are our 2 maintainers. So Bart, who's the maintainer of MapLibre Native, and Harel, who's the maintainer of MapLibre GL.js. Yeah. So if you ever have a pull request, in these libraries, you will probably get an answer from them. Yeah. Yeah, so these are the core projects. Then besides this stuff, we have a sort of a formalized governance. So the MapLibre organization, it was a bit, when we started, was a bit difficult because we said we want to have a governing board, the board who does the strategic decisions and so on, and has the last word on all decisions in principle. But then the question was like, how do we get these people? And we thought like, let's do an election, but like, who should elect them, right? Because it's a project where random people show up on GitHub. So we defined a group of people, which is the MapLibre voting members, and they have the right to elect the board members. And the other thing which they can do is they can vote on changes to the MapLibre charter. So the charter is our document which codifies the governance. Yeah, so these are the 5 current board members, and they should stay out, ideally, from like technical discussions, like which pull requests to merge or which not. But should we ever end up in a situation where like we cannot resolve problems by just discussing or so, they would have the last word. MapLibre is financed by donation from sponsors. So, and the large sponsors that we have are listed here. So we have just a membership fee. If you want to be a sponsor, you have a membership fee. You pay every year a certain amount of money, and with that we fund the maintainers and the coordination work. That's how we are funded. And so this sort of so for the sponsors, this is also interesting, not only because we maintain the repos, but they can also build connections between each other. And one example of this was the metal migration. So MapLibre or Mapbox GL.js was created more, I think 10 years ago. They had the anniversary. And back then there was just WebGL and OpenGL on it. So that were the APIs that they used and implemented. And on iOS, on the Apple devices, OpenGL was deprecated, so there's a risk that at some point MapLibre Native doesn't work anymore if we only have the OpenGL backend. So they actually made a graphics backend with MapLibre Native, with MapLibre. And that was the collaboration between 2 of our sponsors. So the deal was that Amazon pays the contractors, and Meta gives one of their full-time engineers to work on the project. And that was an effort which was more than a year long. And we released it, I think, at the beginning of the year, right, Bart? And yeah, so we have Metal now, and it continues to with an Android, for Android with a Vulkan backend. It's cool to see that they, because we make sort of the forum for them to meet and exchange, that they then can collaborate and build stuff. Yeah. So let's switch now to text rendering. So yeah, if you think about text rendering, then I think we can break it down into 3 stages. And the stages are, so, you know, like just on a high level, if you want to build something like Microsoft Word, Google Docs or something which just has to render text, right? What are the things that you actually need to do to get from what you have in your data to something you can display on the screen? And I think we can break this down into 3 stages. The first one is you have to segment the text. The second is you have to shape it. And the third is the rasterization. And to understand what segmentation is, let's start with shaping. So the second step, basically. So the responsibility of shaping is you have some text, often that's stored as strings, like in the Unicode format, and then you have some font, right? And then to turn this into something which we call the positioned glyphs, or the thing that you can put on your screen somewhere, we need a shaping engine. So let's have a look at a bunch of examples for fonts, or what a shaping engine does for us, basically. So this gray box is, you think of it as a font, and the font has 2 parts. One part is the glyphs, or just vector outlines of the thing you want to render. They are stored in Bezier curves or something like that. And the other part of the font is a set of rules. And the rules tell you how to map like input text strings to positioned glyphs. And the rules are interpreted by the shaping engine to basically, so you give to the shaping engine the rules in a font file, and the text you want to render, and the output is the position glyphs. So here, this U+ thing, that means it's a Unicode code point, we call it, and it's in hexadecimal format. So 41 hexadecimal 65, which is this ASCII A, capital letter A, right? And this font is very simple. It just has 3 glyphs, and it supports 3 input code points. And each time you get one of those, you just output it, like just a 1-to-1 thing. So that's maybe the simplest font we can pick. Now, there's more things that we can do with this sort of rules. So one is it's a process called kerning. Maybe you have seen this before. If you have an A followed by a V, the V gets shifted a little bit back. So if you just, so this font has now 2 glyphs. A maps to the glyph A, V maps to the glyph V. But if you put the 2 after each other, then you want to move the second, the V, a little bit back. And here we see a bit now what is meant by a positioned glyph. So it's really just the glyph index plus some positioning, the X and actually Y position, because sometimes you have to move a glyph bit back or up and so on. All of these things can happen. That's this sort of the concept of a glyph. So that's kerning. If you shift stuff, for example, also capital T followed by a lowercase e, like in Texas, then E goes a bit under the T, stuff like that. That's kerning. That's the shaping engine traditionally.
Is this kerning like defined by each font individually? Right?
Yeah, so the font, exactly, because yeah, it depends how your glyphs are, and the font designer actually decides, like, I want this amount of kerning, for example, and they go back and forth. Like that's what it is in the font file. Again, like glyphs and the rules. And actually, if we, at this stage that we are right now, which is the shaping stage, the outlines we don't care about at all. The shaping engine really just interprets the rules. And later, when we do rasterization, we will take care of the position. Okay, but I think we have some more things that the shaping engine can do. So, ligature. Yeah, that's a good one. So this font has 3 glyphs now. F, I, Fi. And you see the F eats the dot of the I in this example. And so here, depending on the input, the rules are, if it's just an F, give me the F glyph, or glyph 1. If it's just the I second glyph, or if it's the 2 of them followed by each other, then give me the ligature, which is a third glyph. And actually, if you see on the Microsoft logo, EF is also ligature. So people can play with this in logos also. But like anyway, so there's this sort of thing which can happen in text rendering, like ligatures. See what the next example is. Combination. Yeah. So this N tilde. In this font, this is an arbitrary made-up example, right? But you can think of that you make a font which has one glyph, which is the N tilde. And if you get, so Unicode has a special code point for this N tilde, like for the whole thing. And that's this F1 or 00F1. That's one way to render this one. Or if you get an N followed by the tilde. So there's also a code point for just the tilde, which combines with the previous one. Then that's so this sort of combination of code points into one glyph is something. And finally, I think, yeah, not only the input text matters, but there's also more settings which can play a role. And one of them is the language, actually. So there's in Unicode, especially for Chinese, Japanese, Korean, these three languages, you can have different rendering depending on what the language is. I think also in Hungarian can look different. So it just matters which language you tell the shaping engine to use. And in this font example here, you actually get a different glyph depending on what the language setting is. Yeah, so in here, Japanese or Korean gives you a different glyph. This glyph, I think, or this letter means knife edge. Yes, so now coming back to the first stage, basically, we see that if you have a shaping engine, what matters is the font, of course, and the text you give it, plus a bunch of settings. And these are a language, but can also be script. So say the Latin script, the Cyrillic script, or the Greek script, things like this. The direction matters. For example, Hebrew is rendered right to left, while Latin is rendered left to right. So you have to specify that as well. Plus something which is called variation settings. So that in a font, you can say you want the font weight, like how bold it is, for example, you can specify that, and the rule might change based. So all of these things have to, each time you call the shaping engine with a bunch of text, all these settings have, like these settings here, they have to be constant. So at the beginning, before you send your text to the shaping engine, you have to segment it. So if you have text which has Latin and Arabic, you have to cut it in pieces, and then first shape the Latin, and then the Arabic, and then the Latin again, stuff like that. Because all these settings have to be constant. That's something you have to do. For the shaping engine itself, there's a very good open source tool for it, called library. It's called HarfBus. Yeah. There's also like the proprietary tools like, I think it's Cortex on Apple, Cortex, and Direct Write on Microsoft. Yeah, so anyway, like, but there's also a very good open source shaping engine, which is, for example, used, I think, in Chrome. Yes, so, okay, so now we have seen these two stages, segmentation and shaping. And yeah, so your question is probably like, now, does MapLibre use a shaping engine? And the answer is actually no. So MapLibre, or at the time the Mapbox engineers, made the simplification of saying, we just say every code point maps to one glyph. And that works reasonably well, for example, for Latin characters. Greek alpha, it still works. Here, yeah, like this is the Korean or Japanese letter. Now you can't distinguish between which one we get, right? Because we don't know the language. So this sort of assumption makes the whole engine much, much more simple, right? Because you don't have to have a text shaping engine at all. And it works well for Latin, Greek, Cyrillic, yes, CJK, which is Japanese, Chinese, Korean. And we have a bit of a special logic still to handle Hebrew and Arabic, which are right to left languages. But basically that's it. And where this really hits the limits then is in this unsupported script in South and Southeast Asia. So it's mostly index scripts which are affected. And I listed here just a number of millions of people who speak these languages. You see, like it's all of this, and down to Cambodia, where you have Khmer, and it's like I don't know, like 500 million, 1.5 billion people. Probably it's even more, but because I think India is alone already at 1.5 billion. Yeah.
And Unicode cannot add those scripts.
They are in Unicode, but the thing which happens is, for example, if we look at Devanagari, which is the script for Hindi, the language, then it has a lot of these things which we saw before, like ligature or reordering. You know, maybe the text appears as ABC equivalent, but then you have to render it as CAB. And things like this, our like MapLibre, it's just wrong. And also we saw this N tilde.
Yeah.
In Khmer, you have this a lot, and you have these things which look like mustache or whatever, and you have to place them above and below, and there can be 2 or 3 of them above and below. And that's just MapLibre doesn't know anything about it. So yeah.
And the text engine takes in code points and gives you out glyphs, or and why does that is that a black box? Like if you added that in, why does that add complication? You brought up that it was complicated.
So your question is, if this engine exists, why don't we just use it? I think nobody ever cared enough to put it into MapLibre or GLJS or native. And also one has to say, when this was designed, HarfPath was maybe not that stable. It existed already, I think, but maybe it was not that popular. Yeah. It's a C++ library, so if you want to bring it into MapLibre GLJS, you have to probably do it in WebAssembly. It's not impossible, but it's a few hundred kilobytes you have to ship and so on. Yeah, but yeah, the architecture which we have now is really like you get code point in your string, you know you have to use this glyph. That's very simple in the code. And if you have a position glyph, remember you take into account also the XY positioning and so on. So the code has to change. But yeah, that's just where it is at the moment. But yeah, I mean, I think we should put it in MapLibre.
Out of interest, do you have any support for emojis?
Also not. Yeah, emojis make so. Even if we forget about color, which emojis often consist of like 3 or 5 code points, which all get together. Like the eyes are one, the smile is one, the nose is one, and yeah, this is something that the shaping engine does as well. Like this combination of code points with a font. Okay, so but that's just how it is. Now regarding the last part of this pipeline you have to do for text rendering, the rasterization. So the problem that is left now basically is you get in your font, you get the vector shapes, right? These are Bezier curves or so, but you want to color pixels. So that's something you have to do. And now if like, so for example, the requirements that we have in a map renderer are basically that you can move, like say rotate, pitch, and scale your map very fluidly in real time, 60 frames per second or whatever, and the text should just scale very nicely, right? So it should be really fast rasterization. That's one thing that you want. Felix, you mentioned outlines. Absolutely, it's very important for text on maps because maybe your text is black. Maybe you have some black outlines of streets or something, and then you have to have an outline. It's just there's too many colors in the background of the text to not have outlines. So these are things that we want. And in the example we will go through now, I took this example shape that we want to rasterize. It's not a letter, but say if that's something we want to render. And I'm using pictures from Viktor Shlumsky. He has written nice master thesis about text rendering, and you find this GitHub repo. It's a very useful GitHub repo. You find the master thesis there as well. Yes, so, okay, let's start with the technique that we are using. So it's called the sign distance field rendering method. And imagine now we have this outline. So the outline is a vector shape. And what we do is for each pixel, on this 16 by 16 texture, I think it is, we asked the question, how far is it away from the outline, right? So this is just, this pixel is minus 1.8 away from the outline. It's just the length of this line. And it's negative because it's outside. If it's inside, then you do it the other way, right? It's positive. And if you just had to, just rasterize this, what you could do at this point is the pixels which are nicely inside, you just make them black. The outside ones, you make them white. And maybe on the border, you make them a bit gray, depending on how far it is. But that's not what we are doing with signed distance fields. Instead, we store this sort of data, the distance from the outline, in the pixel value, in the pixel color, if you. Okay. And now, if we think about what this means now. So what is done here in this picture is, for every center of the pixel, we draw a circle with the size of the distance, right? So, and we know the black area, which, for example, this, we know it's inside. Because from the pixel center, it has to be that far, the outline has to be this far away. So we know this part is ish. And vice versa, on the outside, everything which is white, we know it's outside. And then the red painted areas are not in either inside or outside circles. So you don't know. And intuitively, you could think now like, oh, there's a lot of red. Probably the result of this reconstruction of the original shape will be quite ugly there. Surprisingly, it's not. And the reason is basically this. So in this picture here, what's done is you have on the white, where the white lines cross, that's where your pixel, like the values are that you know, like in in your signed distance field. And then you interpolate it on this thing, right? On all the points between. You make an interpolation, and the result is, it looks like an island, right? Or like a double island. And what you can do now is it's like water. An island sticks out of the water, and at the threshold you cut, and then that's where you reconstruct your original shape. And you see, like, you can, if you just take the green outline, it's perfectly exactly what we had initially. So there's this problem with the red areas isn't here. As long as your shape is smooth, you will get a perfect reconstruction. And it's also, you remember initially we had the requirement that we can do outlines. No problem, you just put the water a bit lower, and then you have your outline, a shape which is a bit bigger than the original. And the other one is we want to have a very fast scale, rotate, and pitch, and so on. And that's also easy and fast on a GPU, because GPUs are fast at sampling textures. So you take your textures, you think about how you want to sample it with basically another grid, and then you do it. And then you have it. You can do it all in the shader. It's very fast to run. So that's why, I guess, why people like to use SDFs on maps. But there's also a bunch of downsides to this approach. And the main one is that, okay, it's good for as we've seen before, with like these sharp edges of shapes. It's very clear where the shape starts and where it ends. For example, here on the A, here is the edge. But what it's not good for is to detect these corners. And you imagine if we think back of the red areas, if your corner happens to be in the red area, then you don't know exactly how to read. So in this example here, that's the original A. That's with a 16 by 16 texture and SDF, and here double resolution. You still see these rounded corners. It's just an artifact you will always get from SDFs. You cannot get sharp corners. Even, yeah, like Felix, you had like actually sharp London and so on. I think you used like, I don't know, 100 by 100 or so, like, or
170.
100. It's just, you have to be huge. Yeah. These SDFs get huge if you want to have something which looks sharp, and then actually you run into problems if you show your text small. For small letters, doesn't work. So I would say it always reminds me a bit of sausage fonts. It's ideal for sausage fonts, this technology. And if you if you look at some of the map providers, they actually use sources fonts with MapLibre or Mapbox, and that's where it looks good. But if you want to have these sort of big letters, then you get the artifact. Here's a little comparison between Apple, Google, and MapLibre. And I used the meta map style, which is one which has nice big letters. So they were a bit bold, and they said like, yeah, let's anyway put big letters on it. And I mean, I'm a bit now. Maybe it's I'm too picky here, but like the Google Maps L has a nice sharp corner here. Apple also. Yeah. What I cannot. I now I immediately see if something is made with MapLibre or some other technology, because just the text looks rounded, and yeah, it's. I think it's a bit a downside. Yeah.
Have you looked at multiple sign distance fields?
Yeah, exactly. So that's one technology that you can use instead of one sign distance field. Can have multiple. That the link actually to Victor Klumsky is he made his master thesis about multi-channel sign distance fields. And there the idea is that you have to be in multiple shapes inside, and then you can with like 3 sign distance fields together, and then you can get sharp corners. That's maybe something that MapLibre could do in the future. Or
Is this something that Google and Apple are doing?
I don't know. I think Google or someone has a patent on a text rendering technique which runs on the GPU, which runs out soon. So maybe they use this one. So there's alternatives to this SDF text rendering. It's just that this is a typical artifact you get, like rounded parts. And it's not only on text, it's also on icons. It's everything you display as SDF.
Mapbox, is it like MapLibre, the same?
Yeah. Small thing about the way stuff is handled with the data in MapLibre. So we have these glyph ranges, we call them, and they are stored the endpoints like this as files. And we always pack 256 glyphs into one file. So inside this file, you will have like the glyphs for all these code points, and it continues for. So you see, maybe this is Latin. Here we have 3, and then it goes through all of them. That's the way this stuff is handled. And then on the client, you just load the ranges you need. Then you put the SDF textures together into one big font atlas, which is made for the frame you're rendering. Way it's done. And then finally, a small note about tiny SDF. So if you go back a few slides to this, right? Ideally, you compute the distance from your SDF pixel to the shape with like a vector calculation. You do the Bezier thing and so on, and but then you go further. You compute everything. That gives the best result, but it's a bit slow, and it requires you to have the font. But if you have, in the case of, there's an alternative basically, and that is you use the browser canvas in the client to rasterize something, for example, this knife edge glyph, and then you do a raster to raster conversion. So you take from your canvas, you take the grayscale image, and then you convert that into an SDF. And it's very fast, but it gives you more artifacts than the other approach actually. The quality is not as nice, but you can do it in the client because it's fast enough, and you don't need access to the font file originally, because you can just ask the canvas to render something for you. You can use system fonts by your browser and so on. And like that for CJK, it's very convenient because CJK has tens of thousands of code points. And if you can, of course, load all of them from your server with the glyph ranges, but you will have to load a lot.
The thing is that generate what you need in one text with the field, right?
On the client, you say? Or? Yeah, absolutely. You do this on demand with tiny SDF for CJK. So my little wish list for MapLibre and text rendering, I guess, is that we find some way to bring a shaping engine in and be able to like render text in South and Southeast Asia. And then also maybe we can think of a future replacement for SDFs, that we get like this sharper text, but also like better icons. If someone wants to make a big icon with an SDF. Yeah, with this, I thank you for your attention. Yeah.
So WebGL uses almost exactly the same technique. Only difference is we always generate the font atlas on the fly with tiny SDF.
Yeah.
I wonder, if it's a common interest to bring a shipping engine and maybe to employ other rendering techniques, maybe we can join efforts and make a shared module.
Yeah, I think that could be interesting. I guess it's Harald, what do you think about it?
Yeah, I think it's a good approach. I think it would be very inclusive, which is what we want.
Yeah. And often people use the two libraries together. I think they would also like it if you can have sort of the same expectations from the two.
Yeah, I can't tell, if we want to run like how much dependency it's going to add, but at least if it's the same thing that we are going to use, maybe people only have to bring it in once.
Mm-hmm. Yeah, that's true. Mm-hmm.
As an added bonus, the text will look the same, so that's quite nice.
Yeah, absolutely. Yeah. Yeah, the one thing to be aware of with tiny SDF, which I found people, if you have a good display, like this, the double resolution display, the retina display, then you don't notice so much the difference between the tiny SDF approach, which is rasterizing a raster image, and the vector approach, where you make the SDF from Bezier curves. But you should try it out once with like for example, with MapLibre, just a single resolution, and it looks actually much worse. Yeah, that's just something to be aware of.
SDF looks worse.
Yeah, tiny SDF. Often like that, there's a bunch of artifacts. The most disturbing one, I find the baseline. So if you look at text which is made with tiny SDF, every letter will be like 1 pixel lower, higher, and so on. Anyway, like something to be aware of.
When I was playing around with it, just very much zooming into this distance field and seeing that this is like really far from the one that you had there. Just weird artifacts like banding and stuff like that.
Yeah,
I mean, it's tiny, it's fast, so that's
exactly.
Yeah, but
tried rendering time distance field into the double resolution and then the aliasing them into them.
No, I haven't.
even when I had mine at 170, then you just see weird. The console is just unpunched in some places. There's something strange going.
Yeah. Yeah, but
Can you talk a little bit about the work you did for the NLNet grant for proto maps?
yeah.
Around this problem.
Yeah, I was thinking. So if you go back to like this map here, or where was it? Like these languages. Or if we even go back one step here, one thing which you can do if you want is in Unicode there's an area which is not used. It's called the private use area, and there you can put whatever you want. And so what we did there was like we just replicated glyphs and put them there. So if we look at the n tilde, for example, well, for example, this n or like this tilde, it could be at different heights, right? And what we did is like for every positioned glyph that we find, we make a new code point in the private use area and store it there in a glyph range. So for example, the tilde could appear like 20 times because like an N, it's at a different height than at a capital A or something like that. So you can in principle do this server-side shaping, but then in your text that you put in the vector tile, you have to use the code points from your private use area. So you don't use the regular code points, but you use the stuff that you generate. It's if we go back to this slide here, if you want to render Devanagari, then you have to go through a shaping engine. So you have to do it somewhere. You can do this at the client when you render, or you can do it when you generate the tiles, knowing what font you will use it with. That's possible. You can do it wherever you want, but there's no way around the shaping.
You need a custom font, right? If you use this.
Yeah. So if you do that, then you do a strong coupling between the tiles and the fonts you're using.
If I want today to make add let users add annotations to a map, like arbitrary text. What would you recommend to use? Libre, WebGL text layer, Canvas, SVG, or HTML?
I think as soon as you can use the browser, then you're fine. Then you can put whatever you want. So I think that's the best if you have text that doesn't render with MapLibre or WebGL.
HTML.
Yeah, or SVG is also fine. Yeah.
The advantage of GPU rendering is like if you have lots of text, right?
Yeah, exactly. And you want to be able to tilt and rotate quickly. I think you could also rasterize it with the canvas and then take it from the canvas and put it on your map, but that gets very slow.
Or like fancy effects like what Felix was showing yesterday, right?
Yeah, exactly. I think actually Tilezen used the canvas render. So Tilezen or Tangram, I think it was called, right? Yeah, exactly that. Like their web render, they gave the text to a canvas and then took it back and put it on the map. And that allows you to render all the scripts and everything which your browser can render, but it's a bit slow. I think styling is also.
Depends on the number of
yeah.
labels you want.
Yeah.
Given the fact that the browser has to do all this,
Yeah.
why not just have an API in the browser?
Yeah, I think it's privacy. Because if you had access to all the system fonts, then you could pin the user. I think that's the, and yeah, like we were thinking of proposing an API like to a web standard or however it's called, right? A friend of mine told me, yeah, you should just propose, it's fine, like it's not such a difficult process, but then I think it has no chance because of privacy. Fortunately, because the browsers have perfect text rendering engines and all the fonts. So yeah.